Any questions of any of the assignments so far? Okay. What we're looking at today is tangent. And tangent is the third of the trigonometric functions that we're going to look at. Now, last Thursday and Friday, we looked at sine, cosine, and tangent. And sine was opposite side length over the hypotenuse. Cosine of an angle is the adjacent side length over the hypotenuse. And the one we're looking at today is tangent. And tangent of a given angle is the opposite side length over the adjacent. And it's the only one out of the three that we don't need the hypotenuse to find its value. That also means that what tangent can equal, the two side lengths, comparing the two side lengths can actually be greater than 1. Because if we noticed in sine and cosine, the value that we got coming out of them was always less than 1. Here, for tangent, we can actually get values greater than 1. So again, our sine of an angle is opposite over the hypotenuse. Cosine of an angle is equal to adjacent over the hypotenuse. And tangent, the one we're looking at today, is the opposite side length over the adjacent. And what we're going to start off with is actually setting up the proportions and finding it as a decimal. So the first one we'll find is tangent of S. Tangent of angle S, which would be the angle up here. Exactly. Because the side opposite this angle, the farthest away from it, would be the 80. And the opposite side length is always going to be the one that does not make up that angle. Because if we look at angle S, well, the two sides that make up that angle are 18 and 82. So the side opposite would be the one farthest away from it. We good? Okay. And the adjacent side is going to be the one next to it, so 18. Why isn't 82 adjacent or opposite? It's the hypotenuse. Hypotenuse. So 82 is the hypotenuse because it's opposite the right angle. Also, it is the longest side. So tangent of S is opposite over the adjacent, so 80 over 18. 4.4444. Rounded to 4 places. And that's all we have to do for this here. Now we also need to find tangent of R. This time angle R is over here. And the side opposite angle R is the 18. So opposite side goes on top. And the adjacent side would be 80. Because no matter which angle we have, for this one here, the 82 will always be the hypotenuse. The hypotenuse will never be the opposite or adjacent side. And to get the decimal, we just need to plug it into the calculator. 18 divided by 80. Any questions on this here? Yes, sir. Adjacent side is always going to be the one next to it, closest to it, the angle that we're looking at. So for angle S, the adjacent side is 18. For angle R, it is 80. It will never be adjacent or opposite. because the hypotenuse will always be the hypotenuse. The opposite and adjacent side are always going to be the ones that aren't the hypotenuse. The hypotenuse? Yes. And it works out that way. Part of our sides inequalities is the biggest angle is always opposite the biggest side. And the biggest side is always opposite the biggest angle. And for a triangle, 90 is always going to be the biggest angle for a right triangle. So that tells us that 39 is the hypotenuse. So if we're finding tangent of A, we know that 39 is not going to be the adjacent or the opposite side because it's set up as the hypotenuse. So the opposite side, the side farthest away from angle A, is the 15. That would be our opposite. And the side next to it that's not the hypotenuse would be our 36. Now at this point here, we just need to plug this into a calculator. 15 divided by 36, which would give us 0.416666666. So 0.4, yep, 4167, because if we're going 4 decimal places, the next 6 would cause us to round up. Any questions on how we found tangent A? All right, let's find tangent of B. So tangent of B, this angle over here, well, the side farthest away from it would be the, which goes on top, because the opposite side is on top, over 15, the adjacent side. And if we plug this into a calculator, 36 divided by 15, we're going to get 2.000. If we're going to 4 decimal places. And that's it. Any questions on this here? Let's look at this last one here. I think one more and we'll be good to move on to the next part. Now, if we're looking at this one here, tangent of J. So we have the opposite side length over the adjacent. Now, the opposite side length of angle J would be 24. Opposite would be 24. And the adjacent, 32. Zero point. You guys an answer for that, Jake? 0.75, and we can throw in 2 zeros to get us to 4 decimal places. And tangent of K would be what? 32, the opposite side over 24, which would give us 3,333. And that's all we have to do for this here. Any questions on any of this so far? We feel good with these here. All right. Well, the only other thing we're going to do with this here is actually solve for missing side length. So we're solving for missing side length here. Well, they gave us 32, yes? And what side did they give us compared to this angle? The opposite. So 11 is opposite to 32 degrees. What are we solving for? The adjacent or the hypotenuse? The adjacent. Right. Did they give us the hypotenuse? Are we wanting to solve for the hypotenuse? So that tells us that sine and cosine we're not going to use, because for both sine and cosine we need the hypotenuse, because sine is opposite over the hypotenuse. Cosine is adjacent over the hypotenuse. So if we're solving any of these here and we're not given the hypotenuse and we're not looking for it, we automatically know we have to use tangent. If we're given the hypotenuse or solving for the hypotenuse, we have to use sine or cosine. So here it's telling us that we have to use tangent of 32 degrees is equal to what over what? 11 over x, the opposite side length over x. Now the steps that we used on Friday to solve, we're going to use the exact same steps. It's not going to change. So the first thing we're going to do is multiply both sides by what? The x. We multiply it by the bottom of that fraction. And we do that because we want this x and this x to cancel out, which tells me that x times tangent of 32 degrees is equal to 11. Now, is the variable by itself? No. So we need to do one more step. Yes, we're going to divide both sides by tangent of 32 degrees. Which will tell us that, well, these two cancel, saying x is equal to 11 divided by tangent of 32 degrees. And again, at this step here, we can pull the calculator up and say 11 over tangent of 32, which is 17.603678982. But again, we're only going to one decimal place. I think it's 17.6. Yes. 17.6. Is what we have. If you included the massive long decimal, I'll still take it because that is still the correct answer. Now on standardized tests, they will probably want a rounded to the approximate place. Any questions on this here? The next one. So, what would we do to start off for this here? So we could figure out if we're using sine, cosine, or tangent. Exactly. Since we're not given the hypotenuse, we can go on and start using tangent. Because the opposite side length is 12, and the adjacent side length is x. Exactly. We're going to multiply both sides by x because that will, for one, get x out of the denominator and remove any and all fractions. Is the variable by itself after we multiply by x. So what do we need to do next? Both sides by? Yes. So these here will cancel, telling us x is equal to 12 divided by tangent of 5. If we plug this in, yes. I think you all said 25.7. And that's it. That's all we have to do for this here. Scroll down just a little bit so it gets out of the watermark. Good. All right, let's look at two more and then we'll be done for the day because this is all we're doing. So if we look at this one here again, well, we're going to be using tangent, and it'd be tangent of is equal to the opposite side length, which is 22, over the adjacent side length, which is x. Then we're going to multiply both sides by x. And we do this so that these x's will cancel out. And it also gets x into the numerator. A little bit easier to solve. Is the variable by itself? No. So we have to divide both sides by tangent of 61. Which will cause these two to cancel out, telling us x is equal to do we agree? And that's it. Well, we can also know that 61 and this other angle here will add together to be 90. Well, whatever that angle is, it has to be less than 61. So x's side length should be less than 22. So yes, that makes sense. That the side length is 12.2. Any questions on this here? Last one we're going to look at is this one here. And again, we're not given the hypotenuse, so we have to use tangent of is equal to the, yes. Because here they switched it up on us and actually made the opposite side x instead of the number. So we do need to pay attention to that because that can sometimes mess us up. Now this time we're going to multiply both sides by 13. And the 13 and 13 will telling us that 13 of 56 is the variable by itself. Yeah, so we can go on and plug the other side into the calculator. And that's it. Questions on this here? So if we didn't have a calculator, what we can use is trig. I misspelled that. So, okay, sure. So this here is what they call a trigonometric table. And these were what they used before calculators did it here. So if we're looking for the last one that we had, tangent of 56, what we would do here is this third row column here is tangent. And I would go all the way down here to try to find 56. But unfortunately, this table only goes to Now, there are other methods for us to be able to get there, and one of them is a double angle formula, which is actually using sine and cosine and tangent in combination to get there. So here, 0 to 45, if I wanted to know 45 degrees for tangent, it actually works out to be 1. Another way we can get there as well, instead of using 56, we can use 34. And tangent of 34 degrees would be here, 34.6745. And go with about using it that way. But this table is the old-fashioned way of actually solving for sine, cosine, and tangent values. But now that we have a calculator, it does a lot of it for us. And that's it. So your homework is on page 441, 3 through 11.